Hey guys, Brycen with Trick Tools here, and today I'm going to be talking to you guys about the differences between a planishing hammer and an English wheel. So if you've used a little bit of one of or both machines, or you've worked in a sheet metal shop, you'll kind of understand that both of these machines do similar type of tasks. So what I'm going to be doing is kind of breaking down how each machine works, the tooling, and how each machine does the same job differently, and how and why it does what it does. So for starters, we have our 30F English wheel here. Comes standard with the 3-inch wide lower anvils, and each one of these anvils has a flat spot machined in it, where it's actually, that's where the metal is being stretched and moved between the two upper and lower anvils there. You'll see on one of the lower radius wheels, the flat spot's a little wider. Basically, the English wheel is stretching metal by rolling material between the two anvils, where your gap between the anvils is thinner than the material thickness that you're working with. So as you roll it through, it's smashing the metal as it's rolling through and stretching it. Pretty simple concept, but I'll explain, how it does what it does and why it does what it does in, certain aspects of where you're trying to achieve certain shapes in a panel. So on a planishing hammer here, you have an upper and lower die. So the upper die is flat, and you have a variety of lower dies. Now we have an 18-piece die kit that you can get with this machine to match along with the 3 lowers that it comes with, and that's going to give you a pretty wide selection of different radiuses to be able to use to be able to achieve different compound curves and different stretching techniques. So it uses an air motor that has an inline air supply from shop air that then in turn lets airflow into the motor, which has a weight inside of the motor that's actually doing the hammering. So when you press down on the pedal, the hammer head isn't actually moving up and down in front of your face that you can see it. Basically what it's doing is, as you press the dies together with a piece of sheet metal in here, when you press these together, the dies are always in contact. So you're using the machine to smash the die, or smash the metal in between them. So these dies are always in contact, and you have a weight inside of the motor here that's actually hammering up and down inside to create the hammering action. So that's the basic explanation of how both of these machines work. And essentially you're doing the same thing. You're smashing the metal in order to stretch it and to move it and to create shape and curve and material. So to explain some of the different tooling in the machines and how they work and how they do what they do and how they do what they do differently from each other, I've kind of drawn out a little bit of what your contact areas are going to look like between the different machines. So starting with the English wheel, we have optional 2-inch wide anvils that have what is referred to as true radius curves, machined into them. So there is no flat spot on a true radius anvil. Whatever radius is stated is what's machined into the surface. And so and then you have the flat spot anvils that have that little wide, kind of narrow to wider flat spot depending on what radius you're going for. And I'll explain the difference of why you have each one of those. So with a flat spot anvil, I've kind of marked out here a little bit of what some of the contact areas would likely look like as you're using those anvils. So with a flat spot anvil, when you have the flat spot machined in here, you have basically the upper anvil is stationary. It doesn't move other than rotating. So you have the lower anvil that gets moved up to apply the pressure in your part. And what the flat spot is doing is allowing you to cover more ground and also a little more consistently. So your contact area with a flat spot anvil ends up looking a little bit like this, where it's basically going to be a straight shape with a little radius on the ends. The little radius comes from the radius that's cut in the die this way. So as the material starts to get past the flat spot, you're going to have just a little contact area where it kind of fades off, and that's going to create a radius on both sides. So as you're wheeling with an English wheel, you apply the pressure up with the lower die, and then you roll the material through the machine. So what your area that you just worked ends up looking like, if you press this lower anvil up, and then as you roll your part through, you end up with basically a path that you've rolled through. So then at the end of it, this, would obviously be kind of a matching end, there. But this is just going to have a straight path from one end to the other. So if you put the pressure on, roll just one, if you just push the material through and stop, your path is going to look like this. It's going to look like just a straight line in your part. So in turn, all of this area right here has been stretched. So as this rolled through, it stretched the material, and it's going to essentially most of the time what it does, because of the shape with the radius cut this way and you're rolling in that direction, most of your radius in your panel is going to be this direction, as you roll through there. So, and that's going to change the amount of stretch and the amount of radius and curve that you have in your part is going to change based on the overall radius that is cut in the bottom anvil. So as you get to a tighter radius where you have a lot more shape in here, this ends up being, the contact area ends up being smaller, and in turn stretching that material maybe a little harder, a little faster, and creating more compound curve. So with a true radius anvil, it's the same theory, except for you get an even smaller contact area. So with a true radius anvil, to show you the difference, so this one here, this is our 24-inch radius on this 3-inch wide, and this one here is our 8.5-inch radius. So they're both fairly low crown, but this one has the flat spot, this one doesn't. So the contact area, when this 2-inch anvil meets the upper 8-inch anvil, the contact area is going to be really small. So these are probably a little bit exaggerated as far as what your contact area would look like, but essentially it's going to be more of an ellipse shape. These would be just straight on the two sides, whereas on a true radius anvil, because of where your material ends up, getting stretched and smashed a little bit, your contact area ends up looking like a little bit more of an ellipse. So obviously the tighter the radius cut in the anvil, the smaller and even smaller that contact area is going to get. Same principle, as you roll your material through, you're going to end up with would be more of a straight path through there. But with a true radius anvil, what you end up getting is more stretch through the middle, because essentially when you look at it, when this bottom anvil touches the upper, your contact area ends up being really small. So just put a little dot in here. It ends up being really small, and then it's going to progressively get less through the rest of the little contact area there as you've smashed that metal. So when you put the pressure up there and it thins that metal out, it's going to be a really hard spot, more contact in the middle, and then kind of fade off a little bit throughout the rest of the contact area. And that is just because this is a true radius all the way through with no flat spot. So the flat spot creates a wider path with a more even stretch in it this way, whereas this is a more precise, smaller contact area, and then it's going to kind of fade off as it goes, through the outside as you roll it all the way through. So you'll still end up with a wider path, here, but it's going to be progressively different through the through the radius of the lower anvil. So hopefully that gives a little more explanation on the difference between a true radius and a flat spot. Now, with a flat spot anvil, you can cover more ground. So when you're doing a bigger flat panel, you're trying to achieve low crown, let's say for a roof skin or a door skin, something like that, you want a real low crown. Flat spot anvils are really good for that because they allow you to cover more area in the panel with less passes. So you can make less passes, you can cross your paths, all that, and create a lower crown with a flat spot because you're more evenly stretching the material through your path. Whereas the true radius, you can still achieve those low crowns, but it's going to take a lot more passes and lighter pressure in order to achieve those same curves. So yeah, so that's a basic explanation, or kind of more, I guess, in-depth explanation of the principles of how the anvils stretch the metal as they roll through. So with planishing hammer tooling, the majority of the tooling, because of the way it's made, is all round in shape this way. And then it has the different radiuses cut across the top of the die. So this here is a 1-inch radius. So that's what's machined into here. There's no flat spots, anything like that. It's the true radius machined into there. But there's a larger selection of dies. So we have radius from 7/8 of an inch all the way up to 36-inch radius, which looks pretty flat. So if you look at a 36-inch lower die, it looks very flat, even though there is a slight radius cut in here still. We do have flat dies as well, for certain, flat hammering type applications. But to explain some of the contact area, so as the radius gets flatter in the die, the bigger the contact area gets. So this wouldn't necessarily be a representation of the size of the die, because all these dies that we have for this machine are all the exact same OD as far as they are machined this way. It's just the radius that changes in the face of them. So the contact area grows by the radius being flatter or tighter, whatever. So your contact area is going to progressively get bigger the flatter the die gets, and that's how that works from there. So with the planishing hammer, when you have a part in here, every time the hammer, and I'll kind of turn this on a little bit so you can kind of hear the hammer. So you can hear it tapping in there. So the weight is what's getting moved around inside of there. So essentially you can think about it like as if you were holding a body hammer and you're just hitting really fast. So this is just a way more sped up process to actually hammering on your part, by hand, that sort of thing. So now the faster this hits, typically what I found is the faster this hits, the smoother you can get a panel, because it's going to be more evenly hitting and stretching the metal as you're running it through. The slower the hits, the more you might see the individual hammer marks in your part. But as opposed to, the English wheel, when you roll that part through an English wheel, you're going to end up with a straight path where it's an even stretch all the way down through until you've stopped in your path. Where with a planishing hammer, if your contact area is round, as that hammer weight is coming down to do the hammering and you're moving the metal through, it's going to be, creating a little bit of a different type of action or process in the metal. So as you slide your material through, it's not going to just be a straight line that you'll see a path. You'll actually, if you really look at it, you'll end up seeing little kind of overlapping circles as you're going through. And that's why I said if your hammer's going slower, you're going to see more of these individual type marks. If you just kind of push your part through faster with slower hammer speed, you'll end up seeing more of this. Whereas if the hammer speed is up higher and you're moving your part through a little bit slower, these will be a lot closer together and your path will end up looking more like straight lines as opposed to individual hammer marks where that hits. So the difference of how the planishing hammer is stretching is that everywhere you have a contact area like this, it is constantly stretching the material in a 360 direction. So what I mean by that is when it hits, if this line here represents your thickness of your sheet metal, and you have, let's just say you have your upper die across here. My crude drawing. You have the upper die that's flat on the top, and then you have your lower die. We'll just go ahead and draw a little arch in here, and proportions are off. But if you have your lower die that has a big, a tighter radius on it, when it hammers, it's hammering this kind of small arch shape into your piece of sheet metal. So as it hammers that in there, and then you move over a little bit, if you move too far, too fast, then you end up with another little arch in here and another little arch in here. So the faster your hammer and the slower you're moving your part through, the tighter all these little arches will be to each other, which will then in turn stretch your material more evenly, which will then start to create your compound curve in your base part. So hopefully this explanation kind of gives you a little bit more understanding of how a planishing hammer works differently from an English wheel, as far as the actual action of the machine. So whether it's individual hammer marks, or whether it's a path created by rolling a piece of sheet metal through. And then you might be thinking to yourself, well, this sounds pretty crude. How is it going to make a flat part as opposed to this, where that's just going to make a nice path? Well, that's where learning the speed adjustment, whether it's the hammer speed or whether it's the speed of you pushing your part through a planishing hammer, is going to change all this to where you can get a pretty smooth part. Also, along with that, just like with an English wheel, if you're wanting a pretty low crown, you want to select the bottom die or the lower anvil on the English wheel that's going to have the closest radius in it to the part you're trying to make. So if you're trying to make a really low crown door skin, you want to make sure you pick a lower anvil that has a low crown in it that's pretty flat, that's going to be pretty close to how you want to have your shape in your panel. Same thing with the English wheel, you want to choose a pretty flat lower anvil that's going to create less shape. If you're wanting to go more extreme compound curve, something really that has a lot of shape in it, maybe you're trying to make a little bit of a blister in a panel or something like that, you want to go with more of a tighter radius on the lower anvil. Your contact area is going to be smaller, but the radius will be more aggressive as you're hammering through there. Same thing on the English wheel, your path's going to be a little tighter and it's going to create more stretch. So on the planishing hammer, when this, say this is your contact area, when this hits, if you just do one hit, it's going to stretch in equal directions all the way around. So the metal is going to be forced all the way around equally, as long as your part is being held in there properly and all that. But so essentially the metal is being forced equally out away from the contact area, whereas like I said, with an English wheel, there's no hitting action. So when you clamp when you put some more pressure on that lower die, yeah, you could technically smash a little area that would look like the contact area there, but you're not really doing a whole lot of work until you roll that through and create that line path in your part. So to show you a quick example, so I'm going to turn up the planishing hammer here, and we'll do a couple. I'm just going to run real quick path so you can see some of the hit marks on here. All right, so hopefully you can see this, but there's, as I started, I was going a little slower, and then I really tried to push it through. So you can actually see individual little dots on here, right on that line, as I was pushing it through. And that's what it's going to create, and you can actually kind of feel those as little ridges in there, everywhere that die hit on the bottom. And you can really especially see it there, so that way it's, you can see how it was pretty smooth because I was going slower, and then as I sped up, the individual marks are farther apart. So that's where, if you go next to it, go slower, it is more of a line through there where you don't see, I mean, you can see little marks where you can tell that was the edge of where it hammered, but it's mainly a smooth line based on having those hammer marks really, really close together, kind of stacked on top of each other. Essentially, you're going to get a lot smoother of a product that way. So, I mean, you can see this was totally flat, and just those two paths, this part's getting curved this way, and it will have obviously some curve that way. So that's some of the difference between maybe some of the action of the planishing hammer. Now, with this machine really turned up, that wasn't even really turned up on the air pressure, but if you really turn it up, now, this right here is the beauty of a planishing hammer, as opposed to maybe some of the action of an English wheel, is that right there, I was able to just work the part in a really small area to create a lot of compound curve there. So you can see it's got a lot of curve this way, this way, this way. I mean, it curves in all directions around here because of partly how I was hammering, partly because of the way the contact area, forces the metal out. And then obviously just working a small area like that, you can create little shapes, in a small area. Whereas an English wheel, trying to do something like that is going to be a lot harder in the sense of, obviously you have to move your part through. So to show you that real quick, I've got the tightest radius 3-inch anvil that we have, which is a 2.5-inch radius cut in here. I'm going to drop that in, and just on the other end of this. So the English wheel, when it comes to this part, is all about feel. On a planishing hammer, these dies are always in contact. You can't really apply more pressure to create more stretching in your part in a planishing hammer, because the dies are in contact and it's the hammer weight in here that's doing the hammering. So you can adjust the speed, but not the not the pressure in between them. Whereas an English wheel, it's all about the pressure in between the two anvils. So the more that you turn up on the jack, if you turn the lower kick wheel to apply more up pressure to that bottom anvil, it's going to be smashing the metal more and creating more stretch in your part. So if you wanted to do a really small area like what we did on the other end on the planishing hammer, obviously you'd be over here just moving your part around and doing this kind of stuff, trying to get that same kind of action, which obviously you can do it on a small part, but it's not as user friendly when it comes to something like this. I mean, just a little bit. I mean, you can see a little stretch in here. You can come in and kind of change your angle, change your direction. To somebody a little more experienced, if you've been on an English wheel, you can figure out how to work something like this. You don't need a planishing hammer to do something like that, but it's just not as user friendly for something small like that. So you can see both ends, both have some shape in them. The planishing hammer, you can just real easily slide that around, move it around, get this done in a matter of a few seconds. Where this, if you really wanted to be more accurate with it, I mean, you could be here for a little while trying to, work in your tight area and that sort of thing. So now to talk a little bit about low crown, I'm going to swap out to, we're just going to go to the, this is the 12-inch radius lower anvil, flat spot in the middle. On the English wheel, I'm going to back this pressure off, and then we'll make sure, we'll bring this up a little bit. These are just scrap parts. I'm not making anything in particular, so put a little bit of pressure on there. Now, the beauty about being able to adjust the pressure on an English wheel is that, if you're really just trying to create that low crown, you can obviously use a flatter anvil, but you can also back the pressure off, and it's just going to be doing less work. It's going to be doing less stretching. So once you start working, you can, if you just watch the metal as you're working it through there. If you decide, I really want this to have a little more stretch, you can just bump up on the kick wheel a little bit, apply a little more pressure, and just keep wheeling. Or if you're wheeling and you decide, you know what, I think that might be a little bit too much pressure, you can back off and keep wheeling. It's just real easy to adjust the amount of pressure as you're rolling it through. So with an English wheel, the joke everybody always makes is, oh, it's a thumb smasher. Well, that's true. If you're not careful, you can roll your thumbs right in there and it does not feel good. I pretty much tell everybody you learn that one once, because when you do it once, you learn you don't want to do it again. So always watch your hands. And that's why, again, on a small part, like I said, sometimes the planishing hammer is a little bit easier on a small part when you're trying to work something like that, because you don't have something to be able to get your thumbs in there, or get caught up in there. You can easily do that on an English wheel. It's real easy to just accidentally get a little too close and catch the end of your thumb or something like that. So just always be careful with that. But just a little bit of work there. You can see hopefully some of the paths that are created in here. Now, part of the explanation on stretching metal in general, and it doesn't matter if you're on a planishing hammer or an English wheel, anytime you stretch something in a line, you're going to get more curve on the, or perpendicular to the, to the line that you just ran. So if I ran one line on here, it's going to put a lot of stretch in it this direction. So a lot of times when you're trying to create a compound curve, but a low crown and a big panel, you want to make sure that you turn the panel and cross your paths, because it's going to, if I was stretching it more this way before, now I'm going to be stretching it more this way. And that's what really starts to create your compound curves, is when you can change the direction of what you're wheeling. Roll this through there, and it doesn't have to be parallel. So I was going this way before, now I'm going this way. What I mean, perpendicular. You don't have to be going the opposite direction of what you were just going. You can roll kind of in an X shape, so you can change up the angles to where you're always crossing the paths in different angles through your part if you're trying to create that compound curve. So wheel a little bit this way. Keep rotating that panel around. You can keep wheeling this way. Now this is a lot smaller part, so if I had a big panel in here, you'd be taking big steps forward and back, working that panel through. And really, when you're working a big part like that, it's pretty neat because you can see your lines as you're rolling it through there, which does help, because you can make sure as you roll through, when you come back, you can roll right next to that line you just created and make sure that you're not skipping too many spaces. Because if you roll a line in here and then you come over here and roll a line, you stretched here and you stretched here, but not here in the middle. So you'd end up with waves in your panel and that sort of thing. So, I'm going to swap out this all with some 063 aluminum. I was just working with that real quick to show you some low crown work on the planishing hammer here. So we have our regular standard size lower die, and then we have these bigger, bigger diameter lower dies, but they have the same radius in them. So this is a 12-inch radius cut in the top of this die, but the actual OD of it in this direction is bigger. So I'm gonna drop that one in there. So same principle, what I was just talking about as far as stretching. If I was to run this through the planishing hammer and do a line this way, it's going to create more curve, in this direction. Even though each hammer hit is stretching the metal out in a 360 direction away from the center of the contact area, when you stack those hits on the contact area in a line in one direction, it's mainly going to be stretching in one way. You'll get a little curve in the other direction, but it's mainly going to be creating perpendicular to the line. So if your line's this way, your stretch is going to be mostly this way. So you still, again, even on a planishing hammer, you want to be able to move around a little bit to create that compound curve. So we'll just run this. Now I just did a couple, back and forth there. You can kind of see hopefully the lines that it created there. Because I'm using such a low crown, it's not creating a super aggressive arc, or hammer mark in the bottom of the panel. It's more of a flatter shape so it's not doing as much aggressive compound curve stretching with a flatter anvil as it would with a more tighter radius in the lower anvil. So so if I was doing a bigger panel like this that had that I wanted more of a low crown on, I would keep a flatter lower anvil in here and just keep working. So I went ahead and pretty much stretched out all of this. The beauty and the thing I like about the planishing hammer is that depending on what lower anvil you choose, so with this being a 12-inch radius lower anvil, it's never going to stretch your part more than the radius in that lower anvil. So if you want to make sure, I want to create some crown, not 100% sure what crown I want to go with, but you just need some. Choose an anvil that's lower radius or lower crown radius. That way, as you're hammering, the crown and the panel will kind of sneak up on you. You're not gonna run it through there and then you're gonna go, oh no, it's too much crown in my panel. Now what do I do? Well, there's ways you could fix that, but instead of it going too fast and going too far, make sure you choose a lower anvil that is less radius than what you actually need, or maybe hopefully as close as what you need at first, until you get some crown in your panel, because then when you can hold this up on your part, you can say, you know what, that's enough crown or that's not enough crown. If it's not enough, you can throw a little bit tighter radius lower anvil in there and keep working. So it's never going to stretch tighter than the radius that's in the bottom anvil. So that's a cool part. I've been asked many times of, well, why do I need a planishing hammer, or why do I need an English wheel? And I think, with seeing enough of the differences of how some of these work, you kind of understand that there can be a place for both. It doesn't necessarily have to be one or the other, because there's definitely times where, if you need, a blister in a panel, if you're trying to really put some crown into something in a small area, the planishing hammer works way better for that. If you're trying to create a low crown in a panel, I would say for the most part an English wheel is probably going to be better at a low crown part, and that is because of the more consistent stretching that's going to happen in your path as you wheel your part through. So when you're trying to create that low crown in the English wheel, it's consistently smashing the metal as you roll it through. So as you roll that line through, you turn it a little bit and you just keep working your part. But because it's not a hammering action where you have a weight that's making individual hammer marks, the stretching action that's happening through the path is more consistent. So when you're trying to get that low crown, smooth panel, you can really achieve that easily in an English wheel based on it being just a more consistent action, more consistent stretch, because we're just rolling it through there. So roll that through there quite a bit right there. It's very smooth. You don't feel any little individual hit marks or anything like that. Whereas, you know, on a planishing hammer, I mean, as long as you have a low enough crown, lower die, I mean, it gets pretty smooth. But if you really wanted to, you know, pick it apart, you can probably feel a little bit more, you know, roughness probably isn't the best word for it, but you can just feel the little imperfections in the surface a little more than you can on the English wheel side, because of, again, the way it hits individually versus the way it stretches in an even path. So yeah, so hopefully, you know, this explanation gives you guys some things to think about when you're looking at a planishing hammer, when you're looking at an English wheel and you're saying, why do I need this, why do I need that? Well, I truly believe that there can be reasons to have both of them in your shop, because you know, you're just going to be able to achieve different tasks on each machine and some of the same tasks on both of them too. So and you can also use both of them combined with each other to be able to create even more you know, shapes and panels that are unique, based on being able to create certain compound curves or certain shapes using both of them together in that fashion. So hopefully this video gives you some explanation on these machines, helps you understand you know, why there's both of them, what both of them do. If you have any more questions, you can give us a call and we can help you out with that. But thanks for watching this video, and check us out on our website, Trick-Tools.com, and we'll see you in the next one.